Good afternoon. Thank you to come to the session. My name is Fu Qiao. I'm from China Mobile. The other two presenters, they cannot be here because of the visa problem, so I'm the lucky one. We are from a newly established, what we call as a Future Cloud Continuous Delivery Center in China Mobile. The kind of focus is like when we deliver the NFV network for like 5G and a lot of the new things come and new technologies coming. We kind of figure out that the traditional way of what telco is doing by writing out all those specifications, following the standardized specifications and ask vendors to provide us with the product and put them into our central office is not working anymore when we build all this cloud in a virtualized way. So that's why we established this newly continuous delivery center so that we could focus more on the continuous delivery, the integration of multi-vendors. So in early this year, we actually bring up the first 5G core in SA in Beijing. So in this presentation, we will share some of the experience we have, especially on how we would like to deliver the future cloud. I will first share some of the backgrounds about how the future cloud will be like in China Mobile, what kind of requirements we are expecting. And secondly, I would like to talk more about how future telco cloud CI/CD should look like as we expected. We are not there yet, but we are hoping that we'll work into that direction. And finally, I will share some of our practice on the 5G network integration, more details about the 5G network, how we integrate that, and how we bring them up, and it really works. So this is actually the future network cloud, we call it. We say that we will build new data center, which will be based on NFV technology to support the virtualized and future probably containerized telco services. And we will use SDN to accelerate the whole network implementation, improve the network agility. And then we will also have the new orchestrator here to accelerate the service put online and improve the service agility. So our cloud will be categorized into core TIC and edge TIC. The TIC is telecom integrated cloud. It is what we call for the future, future data center of our virtualized cloud. The core TIC mainly distributed in 8 provinces in China, and will provide the 5G core services for the whole nation. So there will be quite aggregate core cloud. And then the edge cloud will distribute it almost in every cities and counties in China that provide the kind of user plane services, stay closer to the end users. We expect that there will be probably more than 600 edge cloud deployed. And our team is looking more on how to integrate these future cloud. When we look into integration, traditionally integration is something telco does not care too much about. But when you go to the virtualized cloud and future probably containerized cloud, things actually has changed. A few things are probably quite easy to see. Traditionally, we have like all-in-one hardware devices where the vendors help us to put into the central office and it will work. But now you have like x86 hardware, and you have switches, and then you have all different kinds of softwares. And for China Mobile, we actually have hardware switches, OpenStack, Nano, VNFs from all different vendors. So you can count like how many vendors we have to work with, and it's impossible to ask a simple vendor to actually bring up the whole cloud. No one can actually do that. The second thing is about the network connection. Traditionally, there are actually network connections between the board cards, which are solved by the vendors internally. But now the network connections are between the servers and the switches, and also there are virtual connections between those softwares. You have to define both the physical network and the virtualized network, and this makes the whole network planning quite complicated. And also, traditionally the software is actually you cannot see that. We see that it's inside the devices. But now we have to also integrate different softwares like Mano, VNF, OpenStacks, all these things. So we have a bunch of things at our hand. No single one vendor can help us solve the overall problem. So we see that telco cloud integration is actually complicated, and it will actually influence the availability, stability, and agility of the future cloud. We think this probably is the last mile problem for the future cloud. If we fail on this, probably the whole thing about how the agility this cloud will be, how resilience this cloud will be, they will be just some fairy tales to us. So how we prepare to actually have this future telco cloud be integrated? We think that probably there are a few things we need to work on. First, we see there are a lot of new technologies, new architectures. We have the kind of the NFV frameworks. They define the different components, but there's actually no specification that help us define the new integration process. So no single vendor or operator actually know what kind of process we actually should follow. The second thing is about the large-scale component interface integration testing. It really requires automation. And third is about a cross-vendor integration. This is the most difficult thing we met, and we now lack ecosystem. Traditionally, integration is something, there's no ecosystem for that. Integration is something that the vendor work out and give to the telco users. We never say that we should have an ecosystem, but there are competition between vendors. But now if you go to cross-vendor integration, that means that you actually have to build the common ecosystem. Everyone should understand each other. We should have a common language so that we could integrate with each other smoothly. So these are the three things we think that probably we should work on. So here comes to how we think about this future cloud CI/CD should work like. When we talk about CI/CD, a lot of people were just thinking about some develop tools, chains within the software company. But now we are thinking that probably these things will get evolved much larger. For us, we are talking about CI/CD probably across the vendors, the operators' labs, and eventually to the fields, to the data centers that actually in the fields of the operators. So we are thinking that probably there should be two closed loop to build for this future telco cloud. On the one hand, you have to have this loop with the vendor products so that you could do the continuous integration and testing on vendor products to figure out the configuration and interoperability problems before actually have them deployed in the data center. And also, whenever the vendors have their updates, have their changes, they should bring and certified and verified with the other components that actually already in our cloud, so that we can make sure that a single update from one vendor will not tear down the whole cloud that we have already built up. So this is the one hand. Other hand is that we should hold up to the cloud deployment actually happen in our data center. There were I think 20,000 servers we have purchased this year to put in 8 provinces in China. We built like 8 huge data centers for the core cloud. When you actually deploy all these things, you actually have to have different components pre-integrated in our labs to make sure everything can work together. We don't want to meet a lot of problems when we actually go to the data center and solve that. So probably we should have small scale integration before field deployments so that we could solve the integration issues, save the configuration, and then we go to the real field trials and the large data center and repeat all the integration. And if there's any problems occur, probably we could do the problem repetition again, get back to the lab. And also, we could do online operation and feedbacks. For example, if we have some runtime data that could get back to the lab, that we could know what kind of integration issue will actually happen in the real data center, so that we could solve it previously next time. So these are the things that what we see as probably the future CI/CD for telco. And to build this two closed loop is not that easy, actually. First, operators and vendors should understand each other about their CI/CD, so that when, for example, when one vendor has updates, it should be automatically have a notification to the operator's CI system, so that we know what kind of component we should integrate and test this time. And also, we should also have our own CI/CD, which means that we could close the loop between us and the actual data center deployment work, and make things like flow in that way. So this is something that we bear in mind, thinking that we should build with the future cloud. We actually are thinking there are a few things we need to do if we want to build this whole structure. One is about this standard CI/CD pipeline, which means that there will be an open and standard pipeline definition to connect the vendor's lab, the operator's lab, and the operator's field deployments. So whenever there is an update, the others understand the language. And the second thing is about the tool automation, because we will have huge numbers of integration work, testing work that we need to do, and automation is quite important. This includes not only software deployment automation, but also hardware configuration, testing automation, and etc. We actually have done a lot at this part. I will have more further introduce these things in the following paragraph. And the last thing is about we need to build a standard database. Standard database is actually needed so that the configuration from vendor to operators labs field sites can be copied easily. And also, it means quite important because we have this kind of issue, Matt, that we have the hardware from one vendor, and then we have the OpenStack from another vendor. When the OpenStack vendor want to configure the hardware, for example, they want to configure the BIOS, it somehow needs some like human manual work to do all this work. It's a huge work. You have to open every servers and do the BIOS configuration. It takes a long time. So we are thinking that persuade them that how about we build this database so that they could talk with each other using this database, and then we can provide them with a tool that could actually let the OpenStack vendor put the BIOS configuration requirements into this database, and then we translate into some IPMI request so that we could configure the servers automatically. So we're thinking that this standardized database is somehow like the common language that different vendors talking with each other. And huge database can be created and maintained so that operators can also easily get rid of their cloud and know what's actually happening, always have the exact data here. So since we're in this OpenStack, I would like to spend some slides talking about how this open source community is actually working. We see a lot of activities that actually happen in the open source. I myself is working in OpenNFV and also in OpenStack. We see like OpenNFV have their strategy change of having the DevOps as production level DevOps as our new strategy plan. And then I see that in the Linux Foundation, we have the Continuous Delivery Foundation newly established early this year. And also in OpenStack, we have the Zool, we have like Ansible Airship, a lot of things actually going on. They are probably quite, have some relation with this CI/CD scene. So we see a lot of useful tools and brilliant ideas that actually happened in this open source. However, we also see no single open source community actually cover all these and provide the overall solution. So to us, it's like we have to choose our own tool chain and work out our own solution. But this could be a problem because this eventually will make the vendors difficult to fit into different kinds of CI/CD pipelines that different operators defined. That would be something that will draw back the whole agility of the cloud. So we are thinking that probably a community is needed to define this unified operator CI/CD. They probably should be able to set a standard workload, interface, and database, and also provide some automatic tools so that everyone can share the experience. I see some of works that are going on. Like in OpenStack, we have this strategy change. But actually, let's see what will happen next. And also there's a project called XCI in OpenStack focusing on the general event triggering CI with different open source communities. We see a lot of potential in this project, hope that it will go to the way that we expect, help us to do the operator CI/CD. And also I should change it as a CNTT, which is a common NFV for telco task force, which is an ongoing work between OpenStack and GSM and led by a bunch of operators to working on a common NFV platform. We're hoping that this work can at least help us to shrink down the number of OpenStacks, the number of NFV we need to integrate with. So again, a lot of things are going on, but not a major community that actually focusing on this. So getting back to what China Mobile is doing, we actually announced what we call as Open Auto Partnership Program late last year. It is just some quite loosely coupled partner program, which we would like to share some resources with the vendors, and so that we could share the same goal to do the operator CI/CD. For example, we would like to build an integration labs that invite different vendors to have their labs to connect with us to test the vendor verification loop. And then we will have what we call as the automatic tick onboarding system, which will help do the automatic integration and testing. And then we hope that we could define some unified pipeline and interface and database also through this kind of partnership program. And probably do some best practice that we could share within the group. And I would like to share more about what we are doing at the automation. This work is actually, we started this work back into 2017. We think that probably the automation is very important, taking consideration into the huge workload that we have to do the integration. So we built this auto platform. We basically are focusing on things like in 3 categories. We know that there are a lot of automatic tools that the open source communities and vendors are already worked out. So we actually don't want to repeat those work. So we are trying to figure out what kind of gaps all these existing tools already have, and we figure that out and work on that. The first thing is about cross-vendor integration. The kind of example I can give is just now I mentioned about the BIOS configuration. It is quite difficult for software vendors to actually configure the BIOS of the hardware vendors if they are from different vendors. We have this kind of problem when we do the 5G integration, when we do the 20,000 servers integration in the 8 provinces. So that's why we develop this kind of cross-vendor configuration of BIOS so that it could happen automatically. And the second thing is about the customized requirements. Actually, integration actually varies a lot from operator to operator. So we have a lot of customized requirements, and they are difficult actually to realize due to cost consideration. So probably we could work on something that by ourselves and make it easier for different vendor to plug into the system. A quite good example is about what we do as Auto LLD. LLD is short for low-level design, which means that it will provide a common database, lots of data in this database to say how this network will be like. And we see that there are a lot of different vendors. They have their own LLD definition, and they have their own tables and definitions for all these things, and they cannot talk with each other. So we kind of define a common database so that different vendors can talk with each other and share, and then we could do the whole lifecycle data management based on that. And the last thing is about manual testing. That's easy to understand. We are having like 800 NFV test cases, and we have more than thousands of VNF test cases. And these things, if we have to do that manually, that's almost impossible. So we developed a lot of automatic testing tools. We adopt these things like last year in our NFV trials. We provide like more than 100 test cases, automatic testing, and they can be done within like 30 hours. Comparing with traditionally, we will do all this work like in 2 weeks manually. And this year in the 5G integration work, we also provide the 5G NFV testing and the 5G services testing automatically that actually help to speed up the whole progress. And another thing I'm talking about is we actually have a lot of quite mature tools from vendors, from open source, and how should we go work with all these tools. We're thinking of probably could build a common API that could help all these different tools plug into this whole system. We have a quite successful POC with ZTE that we use our common API and have their quite mature integration tools, deployment tools to plug into this pipeline, so that we could, from operators' perspective, we see the kind of the database we have, the pipeline we have, this all according to our definition, and then it will automatically call the deployment tools from the vendor to bring up the vendor's cloud. And it's all in a flow-like way. So we are thinking probably this is something that we could promote in the future. So just a few, we actually announced the Auto version 1.0 late last year, and we're still working on that. So some details about the 5G. We actually begin the 5G commercial trials like late last year. And we have two core network, one located in Beijing and the other is located in Jiangsu province. The one located in Beijing is actually using the standalone architecture, while the one in Jiangsu is actually non-standalone architecture. So the core located in Beijing, we actually provide core network services for 5 cities. And the one working in Jiangsu is actually providing, I guess, more than 10 cities. So that is about the coverage. So our team, we basically help to deploy the Beijing's port and building all these connections. So some key points here is standalone networking architecture. It's based on OpenStack. We have like, I think 5 vendors OpenStack actually in this cloud. It is centralized, and we use what we said as auto tools to do the integration work. So this is like the logical architecture for 5G, just to make you know that it's very complicated. So 5G physical network architecture, we have like our cloud, you know, there are 5 5 cloud here, they are actually based on 5 different vendors of OpenStack. And then we have the core switches here that make them connected to the outside cloud, like to the 5 provinces nodes and to CM9, which is our internet services. So when doing so, we are following the kind of the steps. Like first, we will do the planning and preparation, which auto LLD is working. We use the common database so that all 5 different vendors can define their cloud in a way that both operators and different vendors can understand. And then we got all the hardware and software prepared. And first we'll do the hardware integration. The hardware integration is you have all the servers and switches put on the shelves. You do all the lines connected. And like what I said, we use Auto to do the BIOS configuration. We do some common checking, like whether these IPMN commands is okay, whether the line is connecting with each other right. One thing quite fancy is that previously, when we have all the wire connections between the switches and servers, we will have one man work across that to check if anything goes wrong. And you know that it's impossible actually to check that. So we developed a tool so that we could load into the servers and the switches so that we could check whether everything is okay and figure out anything wrong with the connections, and we could kind of make it correct before you actually deploy the software. And eventually we have the software integration, which means that we will bring up the OpenStack, Mano, and all the VNFM and VNF things. And of course, connecting with the outside services and systems. So we have a lot of issues actually happened. We see that 50 plus is almost like categories of integration issues that we found. And a few things that probably we think is very important. One is about designing. We actually, this is the first time we actually use the ALD we're defining, and we think there are a lot of things that we need to actually improve to make that design more correct and accurate. And the second thing is about adaptation. Although we have a lot of automatic tools, it still takes a long time to do the integration between the NFVI and the Mano and bring up the first VNFs. It takes a time. And we figure out that the adaptation and the debugging is very important. And probably some pre-integration testing within labs will help a lot. And the last thing is about resource preparation. Operators, this is the first time that you actually integrate this future cloud. Actually, a lot of people, we are actually lack of the experience about how to prepare it. So we accumulate a lot of that kind of experience in this whole integration work. Okay, and that's all. Any questions? Yes.
I'm curious as to why you guys have 5 different vendors for the NFVI layer, because that complicates what you're trying to do here. And my thought, and the second point is, in terms of automation of the software layer integration, what have you guys done, and have you guys been successful in terms of cross-vendor interoperability according to the 3GPP specs and validating functionalities across VNFs?
For the question, first question, I know someone will ask why we have 5 vendors. We actually have more. That is, we shrink the number, and successfully it's to 5. And why we have so many vendors? The first thing is that China is a huge country. There's actually no single vendor that has the capability to actually do the whole deployment work and provide all the services for the OpenStack within China. And a second thing is that we hope that we could have more vendors in, so that when something happens to one vendor, it won't influence the whole cloud. So this is just a commercial field trial, like I said. It's not a eventual commercial deployment. We will do the procurement and hoping that number will shrink down, but can't be one vendor. Yeah. For the second problem, we actually are doing a lot about how to do the integration for cross-vendor. Like what I said, we have a very good POC with ZTE that we use the whole auto pipeline. We do the auto LLD at first, build the database, and then we trigger out the ZTE deployment tools, let them read the data in the database and deploy their whole OpenStack. So which means that the auto will build the database, and then auto will help ZTE's tools to configure the hardware, like what I said about the BIOS, the network, making sure that at the hardware level, everything is okay according to the ZTE cloud's requirements. And then we will trigger the ZTE's deployment tools, bring up the cloud. And then we will do some testing. I mentioned that we develop lots of automatic testing tools to make sure that the cloud is according to our requirements. So this is some of the just some trials to see if this cross-vendor thing can work out. Any other questions? Yes, please.
You have SDN integration in your infrastructure?
Yeah, that's a long story. Yeah, we actually tried that like for years. We actually integrate with SDN controllers from multiple vendors like Huawei, H3C, ZTE, a lot of that. But there is something that is quite difficult to us is that we have OpenStack from one vendor and SDN controller from the other vendor. And the problem is the SDN controller vendor should either control the OVS that actually exist in the OpenStack vendors, or the OpenStack vendor should switch the OVS into the one that the SDN controller vendor provide. It is complicated, and we still is not solving that problem. That, I think, is the biggest issue that we do the integration here.
And regarding NVO, you have single vendor strategy or multiple?
Multi-vendor also.
Okay.
Yeah.
Great. Thank you.
Any questions? Okay, thank you. Thank you very much.